All right, we're going to spend a little bit more time on features of sinusoidal functions. Okay, functions that are wave-like and their path repeats over and over. There was three characteristics that you looked at: a minimum, an amplitude, or excuse me, a midline, an amplitude, and a period. So let's take a little bit closer look on how a midline of a function can change. So when we take a function and we start playing with its midline, all that does is raise the function up and down. It just slides it up and down. So these all have different midpoints. Okay, or midlines, I should say. A midline is a horizontal line between a high point and low point. So our midline here would be this pink line. It's halfway to a high point, halfway to the low point. So in this example, our midline would be at the equation y equals 2. It's a horizontal line, so it just has a y in it, and that's equal to 2. So changing the midline is the same as taking a function and sliding it up and down. All right, the next characteristic was the amplitude. So changing the amplitude, okay, is like turning the volume up or turning it down. All right, the amplitude is the distance from the midline to either a hilltop or a valley. So here our amplitude would be 2. The distance from the midline, which is the x-axis, up to a high point is 2. Distance to a midline to the low point is also 2. So this would be turning the volume up, turning the volume down, flipping it. Turning the volume up, turning the volume down. So the shorter the amplitude, the lower the volume. All right, that's our amplitude. The last characteristic that you looked at was the period. Okay, so the period is the distance between two consecutive hilltops or two consecutive low or valleys, minimum points. All right, so let's take a look at the period here. All right, now when I look at this graph, if I asked you, okay, what's the period? If you went by the definition I just had, it would say you got to find two hilltops. But the problem is another hilltop is not on my screen. I can't see where it is. It's going to be over here on the off to the right somewhere. Okay, another low point, well, it would be over here off to the left of the screen. So I can't find two hilltops or two low points, minimums, two valleys. Okay, so the next option is you can use points that are along the midline. So we got 1 point on the midline, and then we have a second point at the midline, and we have a third point. Now, if we want to know what the period is, if I'm traveling to this first midpoint, I'm traveling up. I'm going upward. So upward, 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 downward, 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 downward. Now, I'm back at the same level. But this would not be the period. This would actually be half the period. Because when I reached this point, I was moving downward. But I want to get the period is going to be when I hit that level again, but I'm moving upward. So the second part of this, I'm moving downward, 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 upward, upward, upward. Now I'm at the same place that I started. That entire distance would be the period. So the period in this case would be 18. Now, if you can't see the whole period, all right, then you can take a high point and a low point, and that would give you half the period. So this point is at 13. Okay, this looks to be at about 5. So 13 take away 5 and then double that, and that would be the same as my period. So when we change the period, we're changing the pitch. It's either, if we squeeze the period, the pitch is getting higher. If we stretch the period, it's getting lower. Getting higher, getting lower. And that's the period. Right. Given this trigonometric function, we want to find the midline. Well, we know the midline is going to be midway between a high point and a low point. Okay, so to find the y coordinate, that's the midline, should be somewhere around in here. That's about half. I'm going to add these two. I'm finding the average of the two y coordinates. So when you're finding the average of two, you add them up, and then you divide that value by 2. So this would be, I'm going to add 11 and 3.7. That gives me 14.7. And now I want to take that value and divide it by 2. And I get 7.35, and that is my midline. And now I'm down in the lower, I'm below the x-axis, so this midline would actually be negative 7.31. Okay, now here's the same type of question. You just start with different information. All right, you're told find the midline of the graph. It has an amplitude of 5.3. All right, we know that the amplitude is the distance from a high point or a low point to the midline. So I know that if I go 6.5 and I go up 5.3 units, I'm going to end up at the midline. So that's simply taking negative 6.5 and adding 5.3. So I got opposite signs there, so I'm actually subtracting those two. And then that's the location of my midline. So this is the equation, y equals negative 1.2. All right, next two questions have to do with finding amplitude. Right, find the amplitude. The amplitude we know is halfway, the amplitude is the distance from the midline to either a high point or a low point. All right, so one way that we could do this problem is we could figure out where the midline is, and then from that point, okay, we could find either that distance or this distance. That's one way in order to figure out what the amplitude is. Another way would be to take the distance from a high point to a low point and then divide it by 2. Okay, so to find the space between 2 points, you're not finding the average, you're subtracting the two distances. So I would take 11.4, this y coordinate, and subtract negative 5.5, which means I'm actually going to be adding these two values. So this entire distance is 16.9. So half of it would be the amplitude. So my amplitude is 8.45. The next question, you're finding the same thing, you're just given different information to start with. So we're given a point that's on the midline and a low point. So to find our amplitude, we know by definition the amplitude is just the distance between these two. So to find the distance between two, we just subtract those two values. And my amplitude is 3.4. The last two problems deal with the period. Okay, find the period. So we can find, if we can figure out what a pair of coordinates are between two high points, but I don't know what the coordinates are right there, or two low points, these two or these two, but I don't know any of those. Okay, but I do know a high and a low. So the distance between a high point and a low point, the x distance, so that's this distance in here, this interval, that would be half of the period. So to find the distance there, we are going to subtract out the x coordinates, because we were finding an x interval between that x coordinate and that x coordinate. So to find the distance between two values, we subtract them. So that's really -5 plus positive 1.7, which means I'm going to subtract those two values. All right, and that's equal to -3.3. But we're talking about a period. Period is length. Length is always a positive value. So really all I'm thinking is that from here to here, that's 3.3 units. So then the other half would be another 3.3 units. And my period would end up being 6.6. So the distance between those two is 6.6. The difference between those two, 6.6. And now our last problem. Okay, we want to find the period, but we know a point on the midline and a high point. In the previous one, we knew a high and a low. Okay, but this is where the midline is. So we're told in this problem that it intersects the midline at negative 3.5, negative 0.8. So our midline runs right through here. All right, so I can't find two high points. There's not enough of the graph shown. I can almost get two low points, but I don't know what the coordinates are at either one of those two places. All right, so in order us to get the period, I know that if I can get a high point and a low point, then that would be half my period. So the interval between these two is half the period. Now, where it intersects the midline, that distance is a quarter of the period. It's half of this half, which is a quarter. So from here to here, that's a quarter. That would be another quarter, and I could get my period that way. All right, so we're going to be figuring out what this quarter is, what this quarter is, and then two more of them, 4 quarters, is going to end up making what our period is. All right, so let's see how that looks. Let's clean this up a little bit. I want to find the length between these two x coordinates. So to do that, we subtract. So double negative means I add. Okay, that distance is 7.6. All right. So that is going to be 1/4 of the period of this. Okay, so if I was going to draw that on here, okay, from this point to this point, that's 7.6. Right? Then between these two, that's another 7.6. And I would do that 2 more times. Oops. Take that same segment, draw another one. That's in another 7.6. And then one more. I can't see it on here. But now I've got 4 sections that are 7.6. And then that would end up being my period. So from the midline here to here, the distance in between those, that's 7.6. And that's 1/4 of the entire period. So 7.6 times 4, and there's our period. That's all, folks. See you next time.